Yeah, okay, guys. Once again, very good afternoon. Okay, it has been 4 days since we covered some topics. So in the last sessions, we have covered OOPS concepts and what is OOPS and advantages and what are the main OOPS concepts, and we have gone overview of each OOPS concept, and we have covered what is class and what is object. And I think so we have covered constructor also and inheritance also. In inheritance we have covered different types of inheritance, like a single level inheritance, multi single level, multiple multi-level, hierarchical hybrid, and we know that Java does not support multiple inheritance. So to achieve this, Java introduced one new concept, that is interfaces, and we have gone through some examples. So at the end of these sessions, we will have look at some console applications. Let's see that. So today I'm going to start with another OOPS concept, that is encapsulation. So as we already know, encapsulation is the process of binding data member and methods. We know that data members, fields, characteristics are all the same part of the class, are programmed together to do a specific job without revealing unnecessary details. So if you want to restrict a certain class members to the another class, we can achieve through using encapsulations. So we can define encapsulation in two ways: data hiding and data binding. So data hiding. So encapsulation is the process of hiding unwanted information, such as restricting access to the any member of an object. And data binding. So binding, it is the combination of wrapping data member and methods into a single unit. Mhm. So here you can find the details about the encapsulations. So encapsulation, it is the one of the major part in OOPS concept. In Java OOPS concept, object that refers to the binding. So by spelling mistake. Binding of data and methods that operate on the data within the single unit. So if you talk about technically, the variables or data of a class is hidden from any other classes and can be accessed only through any member function of its own class in which it is declared. So in a simple way, we can thought like, for example, if you have any one class, let's consider student. So if you want to restrict data members of the student class, let's suppose ID, name, address, class, rank, something, etc. If you want to restrict from the other classes, you can do this by making private, and who can access that class members only public method. That means member function or as method or function behavior. Behavior of its own class. So we need to create methods or functions of that two variables of the own class in order to deal with the variables. So in capture, the data in a class is hidden from other classes using the data hiding concept, which is achieved by making the members are a method of class private. So by making the variables or data of a particular class as a private, we can achieve encapsulations. So if you want to access that members and variables, we have to define public methods in order to communicate with that. And that class is exported to end user, and the word without providing any details behind implementations using the abstraction concept. So it is known as a combination of a data hiding and abstractions. We already know abstraction, it provides only necessary details. It restricts unwanted details. So in Java, we can achieve encapsulations by declaring all variables in the class as a private. So if you want to access private variables, we need to create public methods in that same class to set and get. So it has some properties. I mean, it has some rules. In order to get the values, in order to set the values, we will discuss in the class to set and get the values of a variables. So it is a more defined with the setter and getter methods. So these are the some major advantages. As we already know, data hiding. So we can hide the data from outside of the class, and we can increase flexibility. So here flexibility is nothing but let's suppose if you want to access, let's suppose if you want to set values only, I don't want to get the values from the class, and you can do that by using the set method. Or if you are no, I don't want to set, I want to only retrieve. I am restricting to other classes. Hey, I don't want to set, I don't want to update the current values of the class. I need to only retrieve the data members variables of the class. Who can do that by using the get method. So this is the flexible way. And the final one, reusability. We already know it provides a reusability and easy to test. So this is the overview of the encapsulations. Let's go to with an example, then you will understand better. Oops. Encapsulation. Class encapsulation. Div. Let's create main method. So here I'm going to create one class on public class, which is student info. Public class student info. So inside the student info class, I need to declare some fields, some variables like int student ID, string name, string address. So I have created 3 members. So now I need to make it class members as a private too. That means I need to make this entire class as encapsulations. I need to perform some encapsulations. So for that, we need to make this all these variables are class members as a private. Private. And student must be defined its phone file. Okay, we already filed student details. So I have created data members. So let's suppose uh, create one object for student details. Student details obj dot new student details. Let's suppose I want to assign, I want to initialize these values. How do I access? Obj dot. See, if you we know that by using the dot operator, we can access particular methods or members of a particular class. So here we are can't able to access these variables because we made these variables as a private. That means we are restricting that no other classes outside of the classes can't able to access these members. So in order to communicate with the data members, in order to update the values, we need to create public methods of these class members. So there is a some syntax. So there is a we already know we need to create mm, setter and a getter. So setter, it is used to set or initialize the class variables. And getter is used to get the or retrieve the class variables. So is the definition, what is the getter and the definition? Setter and getter. So let's suppose I need to create setter for all these variables. So there is a some rule you need to follow. That is, if you want to set any class variables, we need to use set keyword and you need to use the variable name. Set variable name. Here we need to follow the camel case, not a Pascal case. We need to follow the camel case for setter and getter. So let's suppose here the student ID. I need to create a setter for this student ID. So that means here if you notice the starting character is smallest. But if you want to create setter, you need to follow this format. Set student ID. So this is the camel case. We already know every character of the second word that should be always start with capital letter. So set ID. So set ID, that means we are setting the ID. So that means we need to pass the argument. Here you need to data type and a variable name. And inside this, you can use this. We already know this refers to the current instance variables. This student ID is equal to here whatever you variable name give, that name you need to give. Control copy, control paste, and you need to close. So this is the way setting a particular variable. Next, getter. So like how we define the format for setter, in the same way we can define the getter. Get variable name. So get student ID. Here we are getting, so we are just retrieving the members of the class. So that means we don't have to pass any variable. We can just return. So here you need pass a return type also. Return types are nothing but which return data type, which kind of data type, like integer, character, string, array. In the same way here also. See here we are not returning anything, so it is a void data type, void return type. So here it's a return type, and you need to return variable name, and you need to close. Let's suppose create a getter for this student ID. We are getting student ID. So what is the data type? It is into data type. So for that we need to int, then get student ID. Here we are just return. We need to return the variable name. So student ID. If you notice here, this variable here and here, and here. These are the similar names. That means we are setting and we are getting a initial value for a specific data class variables. So let's suppose create getter and setter for all these members. First one is student ID, public void set student ID. So it is integer student ID. This dot student ID is equal to student ID. Public int get student ID, return student ID. So in the same manner, we need to define getter and setter for rest of the variables. Control copy. So control copy, control V. Set address, get address. Set student ID. So set student name. Here we need to pass string data type. Copy. We need to change the data type also string. Control V. So it is a string data type. It is returning string get name student. In the same manner, control copy address, control V. Set address. Yeah, here we need to change the types string. So now I have created public methods. That means a getter and setter for each and every variables, class level variables. Now I can successfully able to access these variables by public methods. Let's suppose I want to assign initial values, all this. So set student ID. So here you can pass student ID is 33. Obj dot set student name Raju. Obj dot set address Chennai. So now we have successfully accessed and we have successfully initialized. So let's suppose I want to display. So you can create method also. Let's suppose public void display info. Not out.println here id plus. No, I don't want to print here. You can directly print here. Let's suppose, yeah, obj dot get student ID, obj dot get name, obj dot get address. Now, if you run this, now you can successfully see this. So this is the way we can achieve the encapsulations. Let's suppose I don't want to set the initial values. I want to retrieve only. I want to get the values. So for time being, remove the setter for every variable control command. Now see the errors. Now it is throwing error. That means we cannot assign the values. So the one way we can assign the values, we can initialize by using constructor also. We already know. Let's remove this and create one constructor that constructor should accept parameter. So student details. Here you can pass int student ID, string student name, string address. So this dot student ID is equal to student ID. This dot student name is equal to student name. This dot address is equal to address. Now we have initialized, then we need to pass parameter constructor here. Let's suppose give 45 Rani Bangalore. So here we are getting that we are retrieving the values. So that means this class cannot able to modify the existing values. So we are passing these values. That means we cannot modify until unless you create another parameter constructor. If you run this, yeah, this one. Yeah. So if you want to create a getter and a setter and a constructor, there is a one more shortcut. I will show that. Let's suppose take another example. Class. Give me, let's suppose, yeah, area demo. So now I need to find the area. So I need to find the area of a rectangle. So for that to create, I'm going to create one class that is class rectangle area. So for calculating area of rectangle, length and width. Sorry, length and breadth. Yeah. So private int length, private int breadth. Okay. Right. Yeah. Okay. Now I need to create a getter and a setter for these class level variables. You can achieve that by right clicking the current class and you will find the source and you can find the generate getter and setter. So once again repeating, right click, select the source, or else you can see click the shortcut also Alt Shift S, and here you can find so generate getter and setter. Click that. This operator is not applicable to the current selection. Select a field which is not declared as a type that is such a field. Private to tab pin. Okay. Source generate getter and setter. Why it is not? Source. Yeah. If you see this kind of pop-up will appear. Why here it is not appearing? Private input length. Generate data. Yeah, okay. So here we need to select the portion of the code. So here you can find two options. That means the entire class level variables will display here. So you can select particular fields also. You can select only the required fields also. So for time being, I'm going to create getter and setter for all these fields. So select all. So if you expand this, here you will find. So if you want to set, then you can uncheck. No, if you want to get, if you want to get only, then uncheck this. You can do this also for time being. Let's select all and generate, and it will generate. Okay, copy. Let's. So in the same manner, mm, I want to create a constructor also. So create, same, right click, select source. Here you will find source. Here you will find two options: generate constructor using fields, generate constructor from superclass. So using fields, that means parameterized constructor. So generate constructor, it is a without parameterizer. So now I'm going to create only. So let's create a two options. Uh, Create a superclass. I need to generate. Now see the superclass construct has been created. In the same manner, you can generate fields also. Yeah, fields, select all, generate. Now the parameter constructor also has been created. So let's print something. This is auto-generated constructor. Yeah, so we have created class template. Now we can create object. Now we can play around this. Let's suppose create object for rectangle. Rectangle. mm, Rectangle. Rectangle. Double area obj new double area. It is asking parameter constructor. So let's suppose give two values 5 comma 26. That area. So we need to perform operation. Create one method. Public void get area. So we need to create one template here. We need to the area of rectangle is length into breadth formula. So length into breadth. Then we need to print area of area, yeah, area. Let's suppose area. So here find, and we need to call these methods obj dot get area. Now see the area is 130. So if you want to print these values, you can do that. Standard out dot println obj dot, we already know, get length plus obj dot get breadth. And as save. So here it is printing. So if you want to update, the initial values, let's set the values obj dot set breadth. Let's suppose give breadth as a 50, obj dot set length 3. Now you can call get area. Before that, print one new line. Yeah. Now see the let's print the values also. Obj dot get length, obj dot get breadth. Okay, 513. Okay, now we need to print these values. Control X after this. Or is it is showing? Yeah. Now see. So we're passing set breadth as a 15 and length as a 13. So now we are updating the initial values also, and we are performing. So like this way, we can update the variable class members by using public methods of the getter and the setter. So this is the encapsulations. Yeah, okay, guys. Are you understand? If you have any questions, you can ask me. Hello, guys. Are you there?
Yes, sir.
Uh, I hope you understand the encapsulations. If you have any queries, you can ask me. Otherwise, I will proceed further. Yeah, okay. I understand that everyone understand this concept. So this is the overall of the encapsulations. Next one is polymerization, yeah, abstraction. So we already know that abstraction is the one of the pillar of the OOPS concepts. So abstraction is the method of hiding unnecessary details from the necessary ones. In a simple manner, the abstraction process will hide the unnecessary details without revealing to the publics. So it is one of the main feature of the OOPS. For example, consider a car. You only need to know how to run the car and not how the wires are connected inside it. This is obtained using the abstraction, obviously. Here you can find the overall description of the abstraction. So abstraction. Here, abstraction is a method of hiding unnecessary details from the necessary ones. It is one of the main feature of OOPS. Calls we already discussed. So these are the some rules we need to follow. So one is an abstract class is a class that is declared with an abstract keyword. The class which is declared with abstract keyword, that class is abstract class. So abstract is a keyword, inbuilt keyword in Java. In the same manner, an abstract method is a method that is declared without implementation, as we already know. So abstract methods are methods. That means that methods without implementations is called abstract methods. The next one is an abstract class may or may not have all abstract methods. Some of them are concrete methods. Yeah, obviously. Uh, it is optional that abstract class may or may not contain abstract methods, non-abstract methods. So that's why you cannot achieve full abstraction. That means 100% abstractions using this concept. By using inheritance, we can sorry guys. By using interfaces, we can achieve 100% as abstractions. That means that is the difference between abstraction and interfaces. So some of these are concrete methods. So concrete methods are a regular methods. That means so method with the implementation. That is called concrete methods. And a method defined abstract must always be redefined in the subclass. Exactly. So if you declare any method as abstract inside the abstract classes, we need to implement that abstract method in a subclass. That means here we need to use inheritance concepts, thus making overriding compulsory or making the subclass itself abstract. Obviously, we need to override because some properties have the same concepts. So that means we need to override. So, or else, if you don't override in a subclass, then you need to make subclass as a abstract. So, if you extended any abstract class from the subclass, you have to override the abstract methods which are presented inside the abstract classes. Then, any class that contain one or more abstract methods must also be declared with an abstract keyword. We already know that. So there can be no object exactly like how we can't able to create an object for interfaces. We cannot create for you cannot create object for abstract classes also. So there can be no object for abstract class. That is, an abstract class cannot be directly instantiated with the new operator. And then last one is an abstract class can have a parameterizer constructor, and the default constructor is always present in the abstract class. Yeah, we can create parameter constructor for abstract class also, but we cannot create constructor for interfaces. We already know that. So this is the some overview of the abstractions. So let's suppose if you see the real-time example, mm, yeah, one is mm, database connections, database. So let's suppose inside in database you create one method. So inside you create one abstract class that is database. Inside databases you can create some databases default methods. That means every database has some default methods like connect, close, query, query. So these are the some common methods every database has. So that means we can create abstract methods for all these methods and we can override these methods in a different database concepts. The next one is let's suppose um, uh, remote control also. So remote control. So let's have consider our TV. So we are controlling the TV by using the remotes. So that means every TV has a control. That means some default controls like on, off, change channel. So these are the some default methods that every TV has. So we can create abstract methods for these features. So like this way, we have a lot of real-time examples also present, shapes also. That means every shape, like how we declare here area demo. So we are finding the length, we are finding the area. So like this way, we can find different areas for different shapes. So that is also one real-time examples. So this is the abstractions. Let's create one demo. You will better understand. New class, abstraction demo. Abstraction demo. Yeah, okay. So let's suppose I want to create a abstraction for shapes. Shape, that means every other shapes like a circle, rectangular. So it has some default properties. So I need to create a template for I need to create one class as a template. That class name is shape. So inside its shape, let's suppose create one field, string color. So here, if you notice encapsulation demo, area demo. So here we are creating the area, get area for rectangular. So like this way, I need to create for area for different shapes. For that, I'm going to create one abstract method. So by using the abstract keyword, abstract, let's suppose a double area. So see the abstract methods. We cannot create abstract methods inside the normal classes. So we need to create. We can only create abstract methods. The class which is created as an abstract class. Now the error is gone. Next, I need to print a message to the console. For that, I'm going to create one more abstract public abstract to string. Yeah, we have created one class. So let's create constructor source, generate constructor using fields. Let's select the properties and generate. I got control X, control V. Set method as a void. Yeah, we need to return something string. And also create one getter source. Generate getter and setter color. I do only get color. Okay. Set color. Okay. Source generate getter. Red color. So yeah, okay. So I have created one template for all the shapes. That means these are the some default properties for all other shapes like rectangular, circle, triangle. So it has some this kind of properties by default. So let's suppose create one class. Let that class name should be circle. I need to extend. So that means uh, from my circle, I need to extending the shape. So I'm telling to the shape, hey shape, so give me your properties that can help me inside my class that I can reuse your properties. So shape. So whenever you extended, you will see one error. So if we hover your cursor, add constructor. We already know that we created constructor here. We need to call the super class constructor also. Again, you need to add unimplemented methods. So because we created abstract methods without implementation, two abstract methods. One is toString and the another one is area. So I need to unimplement. So now we are overriding the shape of these abstract methods. Circle has a radius, we know that. Let's suppose radius string color. So I need to initialize these properties also for that double radius. So this dot radius is equal to radius. So I need to call the superclass constructor by passing this color. Okay. So we need to find the area. Hello guys, am I audible? So let's short the screen again. Yeah, this one. Where we have, yeah, here. Yeah, we need to find the area. So here I'm going to use one of the method which are provided by Java. Math. So actually math is a class. It comes from the java.lang. So it provide some methods or mathematical functions. It enter space here you can find a lot of methods. You can find minimum, maximum, sine, cos. So you can find different options. So for time being, I need to get the value pi. Pi. Here I am getting the pi value. So formula is next to math dot power. Here we need to pass arguments. That is radius. Let's suppose Q level. So this is the formula for calculating area of circle. So the toString. So actually it is a toString, it is a method. So it prints this values in the console as a string format. Let's suppose. So here I need to return string. So circle color is. So I need to print the color also. So that means we need to access color from this shape class. How do we access? We know that by using the super method, we can access variables also. That means super dot get color. See this, we can call super class methods also by using the super keyword. Get color, that means it will print the color, and we need to print some message. And area is, oh my god. Ah, no. Hello guys, sorry for interruption. I am back. So am I audible? Can you confirm it once again?
Yes, sir.
Yeah, okay. Yeah, thank you very much. So let's start. Yeah, here. So yeah, I need to return color and as well as area is. Yeah, area. So here I need to create main method. Main. So create an object. Yeah, shape. Yes, shape obj1 obj1 is equal to new circle. Obviously, it will ask color yellow. So I'm giving the radius as so 4.5. 4.5. You need to call the toString methods also. obj1 dot toString. It printing something. Control X. Sorry. Yes, perfect. Yeah, now see this color. Circle color is also yellow. So we are passing circle color is yellow and area is something. So that means, so we created template that is shape for other shapes like a circle. So here I am overriding the abstract methods. So these are the some common methods. Here I am overriding. So initially I am, so we are adding additional fields for this circle, that is radius. I'm calling the superclass constructor. That means from the subclass constructor, and I'm overriding the methods, and finally eventually I am printing. So here printing super dot, I'm calling the get color method. That means we created getter for this color. That means we are using encapsulation concepts also. And super dot get color and area is area. We are calling these methods. So finally we created a object. New this is the reference variable. We already know that. So by creating a new, the object will create and the memory will occupy. So created object for circle class. That means circle, it acts a parameter constructor. We need to pass yellow and we need to 4.5. That means the radius. So from this constructor, again it called super class constructor. That means shape. So we are extending the shape class. That means inside the shape class, we have a one constructor that is shape. So we are passing this color, and this color will pass to this constructor, and here we are assigning this color to this class variable, and we are generated one encapsulation, that means getter method, and we are initializing the circle variables also, and finally we are printing. So like this we can achieve abstractions. So I'm giving one assignment. So like this way, so you need to create mm, let's create a class uh, rectangle or rectangle. So create a class rectangle, and then so like how we extended this feature, shape feature like this, you need to extend the shape, and you need to override the all the abstract methods, and as well as you need to perform one operation. That is nothing but here we need to find, yeah, calculate area for rectangle. For rectangle. So this is your assignment. So you need to create one class rectangle. We need to extend the shape. That means you need to use the features of this shape, and you need to calculate the area. Uh, like like how we perform. Like you need to print, and you need to call. You need to add some additional features also. So you need to add additional features for this rectangular arrow in order to find the area. So you need to find, and you need to create a constructor, you need to initialize, and you need to call superclass constructor. So don't worry, I can give this code. So you can implement that feature. This is the abstraction and encapsulations. So let's see one simple applications by combination the abstraction, encapsulation, inheritance. So yeah, here. So let's suppose vehicle rental system. So in this vehicle rental system, the concepts involved inheritance concept, like a different kind of inheritance. And if you see this polymorphism also, sorry, encapsulation. So we have done encapsulation, and we created abstraction. So here we created abstraction, that means fully abstraction by using the interfaces. I need to define, I need to discuss one thing, that is, yeah. So as we already know, mm, yeah. So an abstract class may or may not have all abstract methods. So some of them can be concrete methods. So if you see this here, this abstract class may or may not contain abstract classes. So you can define concrete method. Let's suppose uh, public void show something. Student outer printle. So this is concrete method. So that means we are this is a regular type of method. That means this method has a implementations. So this is a concrete method. So inside the abstract classes, we can have abstract methods as well as a non-abstract. So these are non-abstract methods. So in your, you can call it as a concrete method. So you can call this also. Or let's suppose obj. You need to create a object for this class shape. I don't want to shape. So let's suppose static. So I made this method as a static. That means I don't want to create an object for this shape. So now I can directly access by using the class name dot operator. Shape dot show something. Now if you run this, see this is a concrete method. So that means here you can define some implementations, default implementation if you want to. So that is it is the concrete method. Let's come back to the vehicle rental system. So okay. So I have created one template for vehicle class. So we know that let's consider vehicles like car, bike, jeep, bus. So these are all the vehicle. So all vehicle has some common properties. We know that. So brand is a common, model, interior. So these are the some common properties. Of, every vehicle has this kind of common properties. So and so that means I created protected keyword. You can make it add as a private also. So then I created one parameterized constructor in order to initialize these vehicle class member variables, and I defined getter and setter. Getter and setter under two string. So here we are perfect encapsulation. That means I don't want to access this variable from another class directly. So through these public methods, I can interact. I need to interact. So this is the template, class template for vehicles, all kind of vehicles. Then I have defined two interfaces. We know that interfaces is used to achieve multiple inheritance, and it has methods, that means without body. So I created two interfaces. One is accelerate and breakable. So we know that every vehicle has a accelerate and a brake. That means we can override this feature for particular vehicle. Let's suppose, yeah, car. Let's take a car class. I created car class. So I am extending. That means I am using these features of vehicle features in for this car class. So that means the car has a brand, model, year, vehicle. So now then I implementing accelerate and breakable. That means my own implementations. You can customize implementation, your customized implementation. So obviously for car, we have a different type of acceleratable, breakable. In the same manner, where for bike, we can different type of accelerators. So that means you can override these methods and you can implement your own feature. So here I am implementing acceleratable and breakable. These two feature for car. So that means for accelerated, obviously we need a speed. So without speed, we cannot accelerate. So I defined a private speed. So then rental cost. So that means here rental. So I need to give my car as a rental per day based on the day. So then I create a class constructor. So brand, model, year. We know that. So these three properties are not presented inside this car templates. So but we created. That means we are extending the features of vehicle. So that means the constructor of a vehicle has these features, this class level variables. So we need to initialize also. So for that we need to pass these parameters and here some rental. So this is the current class level variables. So then I'm calling superclass constructor by passing brand, model, here. So whenever you call superclass constructor, so this all fields will initialize with the default values. So then I am initializing the current class variables rental cost per day. So then I am overriding. Now see I am overriding the features, that is accelerate and brake. This few two features I am overriding, implementing for my car. I'm overriding the speed. Initially speed is 0. So whenever I'm calling this accelerate, I'm increasing the 10. So I am printing this speed kilometer per hour. The same way brake. So speed is initial 0 minus 5. So we are printing, I'm printing. Then here I'm calculating the rent for per day. So we know that how to calculate rupees into number of days. So rental cost per day, we need to give the rental cost per day. Let's suppose 5 rupees into 5 days. 5 into 5, 25 rupees for 5 days. So this is the uh, class, sorry, car, and extending the vehicle features. That means we are performing inheritance concepts and we are implementing the some methods, abstraction methods is the full abstraction. You cannot write a body. Let's suppose void print standard out of println. So you cannot write because interface does not support implementations. So in the same manner, I created bike also. I am extending the vehicle. So I am implementing accelerability only. So I am implementing this feature only for my bike. So I created speed and a double rent as usual. Private and accelerating. So I am increasing the speed and calculating the rent. I also created one more feature, that is truck. So I'm extending vehicle features. So cargo capacity or rental cost. So here, this is the parameter constructor. I'm calling the superclass constructor, initializing current class variables and get capacity, and I'm getting the cargo capacity and calculating the rent for how many days. So this is the some vehicles. I created some blueprints, some template for all vehicles. So this is the template. We know we can use these features. Not only these car and bus, you can use this flight, train, and also. So in the main method, so I created object for a car, bike, truck with a different names. So let's about car Toyota Camry 2002. So 2022 it was manufactured. So 500. So if we go to the car class, so car, so it is called rental cost per day 50 rupees. So I'm giving 50 rupees per day. So in the same manner, bike Honda CBR 2021, I'm giving so per day is 30 rupees. The same manner truck also. But here if you notice, we created 4 parameters. 4 F-150 manufacturing date. And if you see this 500, what is this? Cargo capacity 500 and a rental per day. So I'm giving 100 rupees per day. So now I'm calling this, I'm printing on the console references car, bike, truck. So these are the values we pass. So we are printing the car by car. So we are printing. So these values are printed on the console. So now we call, here we are calling car accelerate. So car is accelerating speed 10. So we are increasing. So we are calling accelerate method. That means we are increasing speed 10 km per hour. The same way bike. Whenever you click the bike, obviously the speed will reduce. So 5 kilometers per hour. So here I take initial rental days as a 5. So 5, so I'm getting the car rental cost. So I need to access that method car calculate rental cost. So go to this car class. Here you can find. So calculate the rental cost. We need to find the number of days. So you need to find the number of days. So it is returning double value, double includable, returning rental cost per day. So we know that rental cost, here we define rental cost. So here this value will initialize here, rental cost per day and into days. So 5 days. So 5 days means obviously 50 into 5 or 250 rupees. So in the same manner, we are calculating rental for bike, we are calculating truck also. So this is the simple rental system by using the concept, OOPS concepts, inheritance, abstraction, interfaces, encapsulations. Yeah, okay, guys. Do you have any queries in this? So I will give one assignment. So that means you need to implement some feature to this vehicle rental systems. Yeah, okay, guys. That's it for today. Stop the recording.